the final velocities are negative. If they collide and they go left to right, the final velocities are positive. All right, and if you get confused about what sign something is, then you need to just send up a flag and have me come back there and help you figure it out. All right, that's collision 2. You guys with me on that? Okay, collision 3. By the way, I think this is the hardest one. Collision 2 is the hardest one to get good results on. Because sometimes what happens is you push this one enough faster than this one that they collide. And I think sometimes when they collide, it tips a little bit and sort of digs down into the air track, and then it ends up stopping in the middle. If it ends up stopping in the middle, you may want to try to run it again, okay? All right, so that's collision 2. Now collision 3, we're going to have elastic collisions. So for elastic collisions, you're going to use the rubber band bumper on one of them. And also for the first one, so this is collision 3. You want no masses on cart 2, no masses on cart 1. So put those back in the little accessories box. And some of the rubber bands, this one may snap. This is like a decomposing rubber band. This is how you're going to do the elastic collision. You're going to have the rubber band bumper on one cart, cart 2, and you're going to have what they call the blade bumper on the other one. So it's going to go like that. There is a box of rubber bands on that back table. You may need to replace your rubber bands. So it's going to look something like this.
So the masses of our carts and on this collision are going to be different?
The masses, they may be a little different because I think this bumper doesn't have as much mass as that bumper. But they should still be pretty close, around 200.
Okay.
You'll want to remass them. Good question. So, let's see, what does it say about the position? We want cart 2 initially at rest. And here's where the signs can get really confusing. You just have to think about what's going on. So initially, obviously, this is going to have positive velocity, right? You're going to push it. It's going to go through there. It's going to hit this one. And then I'm thinking, if all goes well, if the masses are close enough, I'm thinking this one will stop and this one will go on. That's what I'm expecting to happen, okay? For collision 3, you with me? Like the billiard ball thing. Collision 4 is when it gets a little more dicey. Now let me look at, so cart 2 is going to be heavier again. So this is collision 4. Now they're both going to start on the other sides of the photo gates. And they're going to collide in the middle. Now, here's the deal. Depending on how fast you push these things, I mean, they're going to collide in the middle, and they're going to bounce apart. So it may be that this one that initially had negative velocity, and you've got to really pay attention to the photo gates here. This is photo gate 2. So cart 2 is going to go through photo gate 2 with, now it's going to have positive velocity. So, are you with me? Unless, sometimes what, and then this one would have negative velocity if it goes back through gate 1, all right? You just have to watch what happens. I cannot predict exactly what's going to happen. Okay, sometimes this happens. This one will have so much momentum that when it hits, that one goes back and then this one still keeps going. So in that case, they both have negative. I have to keep flipping it around because of your point of view. All right, so in all cases, you're gonna calculate the total momentum of the two before and the total momentum after. Now remember, it's mass 1 times velocity 1 plus mass 2 times velocity 2. That's your initial momentum. And then the final is doing that same calculation with the final velocities. So the part that I'm most concerned about, and really I did not leave you enough space here, I would like to see a sample calculation for doing initial and final momentum calculations. So just do all the work for case 1. Show it to me somewhere. You may have to attach a page. And then when I say compare the quantities, that means calculate the percent difference. So I want initial momentum minus final momentum divided by the average of the two. And I want 4 calculations of that. I want a calculation for each experiment, all right? Everybody see what I'm talking about here? And really, I am not gonna worry about the error analysis. Okay? Don't worry about the error analysis table in this experiment. Okay, that's it. Go do physics.